Okay, this is a follow-up. This is like a mini teardown of the Ting microphone that came with the rhythm sampler from Teenage Engineering. So this is a little push button mic that plugs directly in through an audio jack, and it's a very lo-fi kind of crunchy sounding microphone on purpose. It's got built-in effects here that you can toggle, and then it also has the ability to have like sound effects, so like gunshots and the dubstep kind of like that you fire off here. So it's a self-contained little unit. It's really cute. I love it. It's got a little speaker grill, so a tiny little speaker here, and then the LEDs. And then if you take off the bottom housing, you can see the AAA batteries, a volume adjustment dial, a USB-C port, so this can actually be powered externally. Like, I don't have to put these batteries in. I could just plug a USB-C cable in for some reason. It would be powered. So we have 1, 2, 3 buttons, 4. And then if I press all the way down, you can hear another button. So I think there's like a secret little button built in. We have pad printed compliance information on here. We have a handy little belt clip, which is just like a plastic part, strain relief, and audio cable. So I'm going to go ahead and tear it apart, and we'll see what secrets we can learn. Just like the Rhythm, it has these really cool pop-off covers, which I believe are also Lego compatible. I'll validate that once I find some Lego pieces. Cool. Let's do this. Just like the Rhythm, it uses the PH0 screw, Phillips head. Very uncommon on consumer electronics to be this easy to take apart, so thank you again for doing that. I do see like a metal pin here, which would be interesting to play around with. I think that's the hinge pin for the walkie-talkie button. And I'm curious how they make the belt clip attach. It could be a separate part. So, oh, missing a screw. On first glance, I think these are longer screws than the other one, but I would have to take this back apart to double check. Take our housing off, and before we get into the fun part, let's just look at this. For me, this is the fun part. Okay, looks like foam tape to push up against the battery housing. More foam tape to maybe protect the electronics. I see Kapton tape, which tells me that typically this is used for like electrically shorting something, but I think I have another idea for what it's for here. Electrically insulating, I'm sorry. My guess is this captures the strain relief of the of the audio cable. I gotta remember my words. And then this looks like the sub-assembly which holds the hinge in place. And if I open the hinge, I can see there's actually another part here. So let's do it. This is what I was assuming they did. And these are shorter screws. So there's actually 2 screws. The other one was built all with the same screw. Okay, it looks like a separate plastic part is being used for the hinge cover, and it may snap in with something that's covered by the foam tape. Yep. Cool. So here's our hinge. It's a plastic part that just snaps, I think, over the molded in pivot. It's a little fancy. Someone had fun making this. Okay, and there's a rubber part inside too. Wow, this is more complicated than I thought. I bet the rubber adds a little compression, a little bit of the squishiness without using a full spring. This part screws in and has a little undercut for both for a snap hook and to hold this pivot in place. And this is just a mechanical structure to hold everything. It also hides the gate for the mold, which is really elegant. So well done there. Okay, so here is the guts of the microphone. I can immediately see when I press this button in, I am opening a switch here. There's a tiny little contact switch. So in the button open position, not being depressed at all, it's actually pushing the switch in. And then when I depress the switch, or depress this button, the switch is released. So that's probably what activates the microphone itself. We have a ton of test points on this board so they can test it during assembly. I see the microphone cable, the 3.5mm audio cable here. So let's gently pry off that connector, and we can probably just pull this through. Yep, and disconnect it. A big metal insert for the pivot pin, and what else can we see? Soldered wires for the microphone. So that's interesting. I was really impressed by how modular and quick it was to assemble and disassemble the main unit, the Rhythm, but this one actually is maybe more complicated than the it's funny, the mic might be more complicated. Here we are. And then my assumption is if I undo these 4 screws, I should be able to pull the board up just like the synth. Let's put the right screwdriver bit in. Get to it. It feels like they're using a thicker PCB than I'm used to, which may add some of the structure here. So I'll measure that with calipers. I think standard issue PCB is around 1.6 millimeters. These are thread forming screws as usual. Okay, so now I should be able to gently pry this up and out. And I'm feeling some resistance, so, oh, and that's the microphone. That's what freaked me out before. So I really, really, really don't want to sever the mic cable. Let's flip it over gently. And we'll look, and then maybe we'll have to call it here or see if we can pry up the mic cable. Here is what I was expecting, is a separate tack button at the bottom. So once you're at the end of your stroke of this button, this like actuator, it clicks. And these pads and these connectors are a similar style, but actually a different shape to what was used on the Riddim. Same architecture for like holding the button in place, holding the batteries in place, but actually different stamped metal contacts. Same idea for connecting them too. So there's some similarities and some differences, and I'm wondering what's going on here. Let me gently take off these parts, see if I can unplug or remove the microphone, and then we'll dig in further. Okay, this thing gets more and more complicated. Here's our rotary encoder. This has a D profile on it. This has a machined metal hinge pin that pokes through, and the D profiles match so that when you turn the encoder by pressing on this trigger. There are a lot of parts going on in here. So this trigger inside has a like spacer, black plastic spacer, and a torsion spring, which I'm afraid of touching because it might fly away. And then this pin goes through it all to provide this really nice, strong rocking motion. So interestingly, we have a lot of parts at play here. We can kick away the electronics for a minute. But we have trigger, we have this machined metal part, which is expensive. We have custom stamped battery terminals, which are different than on the other synth. We have a light pipe with a secondary process. We have this gain control knob. We have this belt clip. We have this rear housing. We have this hinge pin. And then we have 3 buttons, which are the same but molded. And then we have these 2 covers. There's a lot of stuff going on in a seemingly simple microphone. And again, it has 3 ways of activating it. It's running a Raspberry Pi, so there's some like Linux going on here. This thing's complicated. It's really cool.